Hello students, welcome to IMS Academy. In this smart revision through formula session, I would like to discuss the subject of network theory. The subject is common for ECE, electrical and instrumentation. And also this subject is very important for doing the problems of more in the analog circuits. This subject is it plays a vital role only, we can say now. But we will discuss the number of formulas which are employed in the network theory. So one by one we can start discussing only now. But each and every formula and each and every one of the concept I will give you now. That is going to help you a lot to do any sort of the problem. Understand my point now. So the basics of the network theory we are going to discuss. If the student is very perfect in the basics of network theory, he can do any topic in the networks. Even they want to do the theorems, even they want to do the two-port network, even they want to do the transient state. This basic information is more and more helpful. This, if you are very perfect in this subject, any problem in the analog circuits you can do very easily now. Understand now. I will start the subject of network theory now. The smart revision only done through formulas. We should start from the basics only now. I would like to start from the current. How to define the current? Current or electricity, both are same. Flow of electrons is known as current only now. Electrons are passing through any conductor, we say there is a current. Understand now. That's why flow of electrons or a flow of charges. Flow of charges or flow of electrons is known as current. Is known as current. We can define such a way. But mathematically, how we can define? The time rate of charge is defined as a current mathematically, or we can define like this. Time rate of charge. Time rate of change of charge is best. Time rate of change of charge is defined as a current also. So I would like to take the formula for the current like this now. I equal to dq by dt. I can write capital Q or small q. Choice is yours, no problem. dq by dt is to be taken as a current. Units of current, amperes. It is taken with amperes only now. But here I selected one circuit like this. The resistance R I connected with a supply voltage V. It is going to flow current this side. Current direction is taken positive terminals to negative terminal only now. That is very important now. But suppose you have taken minus to plus, we can give the name I dash or I1 or minus I. I dash is nothing but minus I. We can take now. But what is that I? I is said to be conventional current here. In the network, I can say I equal to conventional current. Conventional current. I dash is said to be natural current. This is said to be natural current. Natural current, we can say that now. So what is that I dash and I, you are saying like this now. I said the definition of the current, the flow of electrons. This is nothing but the conductor. This wire is the conductor that is connected with a resistor R. With a resistor R, I connected here now. Amit Goel. Good morning, sir. Good morning, Amit Goel. This is connected now. This is the positive electrode, this is the negative electrode. Any conductor contains concentration of electrons, more concentration of electrons existing inside. Electrons are negatively charged particles. This electrode is a negative electrode. Negative electrode, electrons are negative. Negative, negative, what happens? Repulsion. Because of the repulsion, electrons are going to flow from this side to this side. All the electrons are attracted by the positive electrode. Due to flow of electrons, the current I dash is going to flow. I dash is going to flow. That I dash is said to be natural current. Natural current. But in the problems, we are going to take only the conventional current only. The conventional current is the direction of the current opposite to the natural current only now. Natural current is always comes with a negative sign. In order to get the positive sign, here taken conventional direction. The conventional current is always taken with positive value only now. That is current. I gave the definition. Next, we can enter into the voltage. What is voltage? We can see voltage. The voltage. What is voltage? The force with it is a simple definition we can see. It is nothing but a pressure. It is nothing but a pressure only. Otherwise, some other way we can say it is nothing but the force which moves the electrons from one point to the other point only. When the electron is to be moved from one point to the other point, it is required some force. When there is no force, it is unable to move to the front. That's why the force which moves the electron from one point to the other point is said to be voltage only here now. So we can define like this: the force which is required, the force which is required to move electron from one point to other point is called voltage only. Is called voltage. Like that we can define voltage. Sir, mathematically you define, formula is required to find out the voltage, sir. Now, yes, V equal to dW by dQ. Work done divided by charge is defined as a voltage only. Work done by charge. Change of work done by change of charge is defined as a voltage only. Units of the voltage is nothing but the V, volts, we can define now. So voltage we can define by using this formula. What about the power? How we can find the power, sir? Next one is the power. Power. It is a work done per time is defined as a power. Work done per time. Otherwise, work done, power equal to work done by time. dW by dt is said to be the power. The power calculation is done by this formula. The work done by time you can define in this way: dW by dQ into dQ by dt. I have written like this now. Just dQ cancel means you'll get dW by dt only. Just modify. We know very well dW by dQ is nothing but the voltage. dQ by dt is nothing but the current. Voltage into current is said to be the power. When you want to find the power, you can use this formula. It is in watts. Units in watts only now. Power. How we can find the work done? How we can find the work done? Work done, if you want to, the power equal to, dW by dt. If you want to find out the work done, you must take dW equal to P into dt. If you are applying integration on both sides, you will get the work done. W equal to integral P into dt. Yes, you must apply this formula to find out the work done. Units are in joules. Units are in joules only. Like that, calculation of the work done is to be done. Classification of elements, I want to give next one. Classification of elements. Classification of elements. The elements are classified in different ways. They are said to be active and passive elements. Active and passive elements. Active and passive elements. The second one is said to be linear and nonlinear elements. Linear and nonlinear, I will write linear and nonlinear. Nonlinear elements. The third one is said to be bilateral and unilateral elements. Bilateral and unilateral elements. And unilateral elements. Unilateral elements. Next one is said to be lumped and distributed elements. And distributed elements. The fourth one is said to be time variant and time invariant elements. Time variant and time invariant, TIV I have taken. Time variant and time invariant elements. Like that we can classify the elements. All these basics are more important to do any question in any chapter. Understand now. The first one I want to discuss active elements. Active elements I want to explain. What those elements are said to be active elements and how we can define. The element which can transfer energy or the element which can amplify the signal is called as an active element only now. Understand? I will explain you as. The element which can transfer energy or amplify signal is called active elements only. This is said to be active elements. Active elements. What are the examples of active elements? Active elements examples I can note down here. Voltage source, any source, voltage source or current source, otherwise source you can put now. Voltage source or current source. And the operational amplifier or transistor, all this comes under the operational amplifier. All these come under active elements only now. But I said which transfer the energy, I said now. If you connected any voltage source, it is going to transfer some energy. That's why it is a active elements only. The next one more definition also given here now, which can amplify the signal can also be said as a active elements only now. The bipolar junction transistor or junction field effect transistor, JFET or MOSFET or whatever it may be, even the operational amplifier will come under active elements only now, because they are going to amplify the signal only, we can say now. But here the point you have to understand clearly now. Point what you have to understand now. Operational amplifier, how it can act as an active elements are now. Is amplifying. What amplification? This is going to amplify the signal. Signal means is it a current amplification or voltage amplification or power amplification will be given importance. if the BJT or FET or otherwise MOSFET or otherwise operational amplifier amplifies the power, then only you can say there is an active elements only now. But we should not say only voltage amplification is done, then we can say it as a what now? Active elements, not acceptable now. Understand my point now. But that must be what now, that is why to amplify the signal means these are all will come under active elements only. What about the passive elements? I would like to discuss the passive elements now. Passive elements. Passive elements means the elements which can store or dissipate energy are called as passive elements only. Example, resistor, inductor, capacitor. These three elements will come under passive elements only now. That's we can define in this way. The elements which can store or dissipate energy are called passive elements only. These are all called as a passive elements. Passive elements. What are the examples of the passive elements? Means resistor, inductor, capacitor. These three elements come under passive elements only. Resistor can dissipate the energy. Inductor and capacitor can store the energy only, we can say. Anyhow, the element which can store or dissipate energy, I said. No. Anyhow, these three will come under the passive elements only now. The next one. The linear and nonlinear elements. Linear and nonlinear elements. Nonlinear elements. Nonlinear elements. But when we can say it is a linear element, it is a nonlinear element. There is a condition, based upon that condition only we can say. The elements whose VI characteristic, I will explain first after writing this now. The element whose VI characteristic curve whose VI characteristic curve is a straight line and passes through origin is called linear only, is called linear. Otherwise non-linear I can say. Otherwise non-linear we can say. Otherwise non-linear. That point is very important now. Here it is given the element whose VI characteristic curve is a straight line and passes through the origin is called linear, otherwise non-linear is given. What is the meaning of this? Suppose VI characteristic curve of linear element I want to draw. Here it is drawn from the voltage versus current. From voltage versus current I want to plot. But I got the shape of the curve in this way. The shape of the curve I am getting in this way. I am getting like this. It is a straight line. It is a straight line. And passing through the, it is a straight line passing through the origin. It is a straight line passing through the origin only. It must pass through the origin. That point is very important. This is said to be linear. This is said to be linear element 1. So it must be a straight line, must pass through the origin, then only we can say it as a linear only now. Sir, suppose any student says, sir, I will draw the diagram in this way. Can you say it is a linear? The voltage versus current I want to draw. That I am getting in this way. This I am getting in this way. I got the shape of the curve in this way. Can you say it as a linear curve? No. The condition it is given, the element whose VI characteristic curve must be a straight line, must pass through the origin. It is a straight line. One straight line is required. This is a one straight line. Next one more line you got. It is not passing through the origin. It is not going down. Two straight lines we are getting. The first straight line, this is a one more line, second straight line, two lines we are getting now. That can't be said as a linear. It is a non-linear only, not passing through the origin. It is a non-linear, I can say. It is a non-linear. Non-linear elements can give the characteristics such a way. The next one, I want to give next one. It's a bilateral and unilateral elements. Bilateral. Next one, I want to give bilateral. Bilateral and unilateral elements. And unilateral elements. When we can say it is a bilateral, when we can say unilateral elements only now. But first I will give that statement, then after I will explain. The element which exhibits the element which exhibits impedance of same. This point is very important. Impedance of same, even the direction of current or voltage, or the current is changed. Current or voltage we can write. Current is changed. Current is changed. Is called bilateral. Is called bilateral, I can say. Bilateral. Otherwise unilateral only. Otherwise unilateral. Unilateral. Before I said linear elements are nothing but the RLC only now. Understand now. Linear, what now? VI characteristic curve, if you want to get, means that's possible from the resistor, inductor and capacitors are the examples only. Understand now. But here the bilateral and unilateral is given. But the element which exhibits impedance of the same, even the direction of the current is changed, is called bilateral, I said now. Otherwise, unilateral. I'll give one diagram, you can understand clearly. Suppose I have drawn VI characteristic curve in this way. Voltage versus current I have drawn here. The shape of the curve is what are this? The VI characteristic curve is a linear I have taken, for example. I have taken linear like this. Suppose I selected some voltage on y-axis. This voltage I have taken V1. Corresponding to this V1, the current I1 is, I can get from this. Current I1 is I1 here. This is the current I1. The direction of the current I reversed. If I reverse one more current, here I will get now. This is a minus, this is a I2 I have taken now. Otherwise, this is a minus I1. Minus I1 only possibles. Minus I1. Otherwise, one more name also you can give now. This is a minus I2 still best. Because that I1 and I2 must be same only now. Must be same only now. But I have taken minus I2. Corresponding to this minus I2, I am getting voltage of minus V2. Minus V2 I got here now. But I ask, can you find what is Z1? Z1 how much I asked. Impedance Z1 is required from the figure. I can note down V1 by I1. V1 by I1 is nothing but the Z1. I am going to get here now. And what about Z2 I asked? What about Z2 I asked? Z2 means minus V2 by I2. Minus V2 by minus I2 I can get now. Minus minus cancel. Finally, I can get V2 by I2 only now. If Z1 and Z2 are equal, you think it's so, then we can say it is a bilateral element. If Z1 and Z2 are unequal values, you think it's so, then it is said to be unilateral element only now. From the VI characteristic curve, Z1 and Z2 values are equal. We are saying it is a bilateral. Or we can say here now, for bilateral, for Z1 equal to Z2 is a must only. Otherwise, it is a unilateral one. Otherwise, it is a unilateral. That is the information regarding bilateral. Next one's lumped and distributed elements. Lumped and distributed elements. Distributed elements. When we can say lumped elements, the elements which are visible to the eyesight are said to be what now? Lumped elements only. Or physically visible, physical elements are said to be lumped elements only. That's again the elements which are physically visible. Physically visible are said to be lumped elements. Lumped elements. These are said to be lumped elements. Lumped elements. Otherwise distributed elements. This point very important here. We can define such a way. That means physically visible elements we are saying as a what now? Lumped elements only. What are the examples of the physical what now lumped elements? Resistor, inductor, capacitor. If you ask to show me the resistor, I can show that. This is the resistor, this is the inductor, this is the capacitor, I can show. If they are visible physically, we can say there is a lumped elements only now. Examples are RLC. These three are said to be lumped elements only. What about distributed elements are now? The elements which are not physically visible to the eyesight, physically not visible only now. Those elements we are calling as a distributed elements only now. For example, you take transmission lines. Any transmission line can have internally resistor, inductor, capacitor. These three are existing only now. Suppose anybody said, can you show the resistor, inductor, capacitor in the transmission line? We cannot show them. Just we can show with a diagram only now. Physically we cannot show. They are internally mixed elements only we can say. Those elements are said to be distributed elements. So example for the distributed element is transmission lines. We can give now. Understand my point now. Next one. Time variant TV and time invariant elements. Time variant and time invariant elements. We can define them. The element whose VI characteristics, the element whose VI characteristic changes with time, changes with time, then it is called as time variant, otherwise time invariant. Otherwise time invariant we can say. With the change of the time, the VI characteristic curve of the element changes using a sort time variant. Even with the change of the time, we cannot find any change of the VI characteristic of the elements, we can call it as a time invariant. That is mostly discussed in the signal sense system only now. Here no need to go beyond that limit only now. Understand my point. The next one, the sources. What are the sources we are going to use? What are the sources we are going to use in the network analysis? What are the sources? We are using the voltage source and current source. The voltage source are the ideal source possible, otherwise the non-ideal source as a practical source also possible now. That I will discuss now. The sources. The sources are of two types, you know very well. The sources are of two types. One is said to be independent source. Independent. Second one is dependent. Dependent source only now. Dependent source now. Independent and dependent source. Two types are there now. Again here independent sources are given two types again. One is said to be ideal. One is said to be ideal source. Second one is practical source. Practical is said to be non-ideal. Non-ideal source. Ideal and non-ideals. Or still you can say still voltage best, still best. We can divide again. We can divide means still we can write like this now. Still extension I want to give. One I can take it as a, one I wish to take it as a voltage source. One is to be taken as a current source only now. Like that I can divide. The sources are divided into two types. One is a independent, second one is a dependent source. The independent sources are divided into two types. One is a voltage source, second one is a current source. But again this voltage source you can divide like this again. One is said to be ideal. The second one is said to be non-ideal. Non-ideal is said to be practical. This is said to be practical only. Voltage, ideal voltage source, practical voltage source. And current sources are also two types. One is said to be, these are also two types only. One is said to be ideal current source, this is ideal voltage source only now. Practical voltage source. But if the current means ideal current source, ideal current source, current source. The second one is said to be practical current source. Practical current source again right now. Current source. Like that you can define. What about the dependent sources now? Dependent sources are divided like this now. It contains models like this now. I can divide like this now. One is said to be voltage controlled voltage source, voltage controlled voltage source. Second one we can say voltage controlled current source. Next one current controlled current source. Next one current controlled voltage source. Current controlled voltage source. Like that we can define. But I will explain each and every one. You can understand clearly now. Ideal voltage source I selected initially. I wish to select ideal voltage source. Ideal voltage source. How to define this ideal voltage source? But I connected one voltage source like this, Vs. But I connected one resistor. This is a variable resistance I have taken for example. We can change the resistance here now. The voltage what I am getting here is a V only now. The voltage what I am getting is a V. Suppose you draw the VI characteristic curve for this ideal voltage source. Voltage versus current. VI characteristic curve I want to drive. The current which is passing through this network, I wish to take it as a I. This is I only. Here what I want to do, I am changing the current I. How you can change the current I? By changing the resistance only now. Because a resistance is a variable. When the resistor is a variable, when the change of resistor is made, current also changes only, we can say. But here the voltage will not be changed. Voltage is going to be maintained same. V and Vs are same. These two are same only now. V and Vs are same only now. It won't be changed. But current changes with the change of resistance. That means I can draw ideal current source VI characteristic curve in this way. Here the V equal to Vs only possible. V and Vs are same. Constant voltage we are going to get. Even if the change of current is made in the VI character, in the circuit only now. This is ideal voltage source characteristic curve. What about the practical voltage source? I will draw now. Practical voltage source. Practical voltage source. But the ideal voltage source, we are not going to consider internal resistance. Without considering the internal resistance, we are going to get now. But here we should consider internal resistance in the practical voltage source only now. I say I connected here the Vs. Vs is the source. Rs is the source resistance, internal resistance of the source. I connected a load. This is variable. Load is a variable here. I am going to get voltage V here. The current which is passing through this network, I want to take it as a I. I want to take it as a Y. But here I asked, can you find the voltage V? The voltage what I am getting across RL I want. The V is calculated by supply voltage minus drop across Rs. Vs minus I into Rs I can write. So here I can say, when you are changing the current I, if you are changing the current I, there is a change of voltage V only now. There is a change of voltage V only now. I say the characteristic curve is available in this way. This is voltage V, the current I. V is nothing but the voltage across RL here I have taken now. Initially what I did here now, the current I made 0. How I can make current I 0? RL is infinity. RL is infinity means it must be open circuited. If it is open circuited, it doesn't flow any current across this Rs. Drop across Rs is to be taken 0 only now. So voltage across this open circuit is to be taken Vs only. I can take this voltage is Vs. Whenever you are changing the RL value you are changing means current also changes only. Because RL equal to V by I. Voltage by current only now. Voltage by current means whatever current is changing means voltage what now? Current what now? When the RL is changing, current also changes. Anyhow, the change of current changes voltage. Finally, what is going to happen now? When current is increasing more and more, you think it's so. Current is increasing more and more. Current is to be increased more and more means the resistance must be decreased only now. Then current is going to be increased. At the time, voltage also increases. That V will be increased. Current is decreased, voltage will be decreased. If the current is decreased, and what is going to happen now? Current is increased, voltage will be decreased only. Reverse it comes. It comes in reverse only now. Because the difference will be decreasing only now. When you are increasing the current, what happens now? Voltage will be decreased. When current you are decreasing, you think it's so. The voltage will be increased only now. That only process will be done. Finally, the shape of the curve, it comes like this now. When the current is increasing, current is increasing, voltage is decreasing, voltage is decreasing, current is decreasing. This is the VI characteristic curve, the practical voltage source. I can write it now. Next one. But ideal current source I want to discuss. Ideal current source. ideal current source. But how this diagram is to be plotted? Ideal current source diagram, how we can draw? In ideal current source, we should not connect any internal resistance. Now, internal resistance is to be considered 0 only. IS is the source current here now. IS is the source current. I wish to connect a resistor R. It is a variable resistor only. It is a variable resistor I have taken now. This current I want to take it as a I. This current is a I. I and IS are same only now. It won't be changed, but there is a change of this voltage. The change of this voltage is possible when you are changing the resistor only now. I say here the I equal to IS. Same current is going to flow. IS and I are same only now. When you are changing the resistor, resistor is changed. Current is constant only, but voltage will be changing only now. Understand my point now. When the resistance is increased, voltage also increases. The resistor is decreased, voltage will be decreased. Understand my point? I equal to IS. And finally, I can note down here now. I can draw a diagram like this now. The voltage versus current I have drawn here now. Just draw current versus voltage we can put, sorry. Say current versus voltage I want to put. This current is constant, that is why. Current versus voltage diagram I have taken up. Due to change of this resistor, voltage is changing. Resistor is increased, voltage is increased, but current is going to remain constant. I and IS are same. This is ideal current source. The variation of the resistor is going to change the voltage, but current is going to remain constant in the network. This concept is required. Next one, practical current source. Practical current source. Practical current source, I can note down. The practical current source I can draw like this now. There is a current source. Internal resistance of the current source is to be considered. Internal resistance of the current source is to be considered in the practical current source. In ideal current source, we are not considering only, we can now understand my point now. But here, how we can draw the resistor which is existing in the current source, that must be connected in parallel only now. That means in the parallel means what I can say here to be taken resistor. In ideal current source, that parallel resistance will be infinite only. Infinite means open circuit will be made now. In a practical case, there is a resistor, that is a RS. This current source is to be taken as a IS. I connected one resistor. There is a variable resistor I connected here now. RL. The voltage across this, I want to take it as a V. The voltage remains same in the parallel network. So this current is to be taken as a V by RS. Voltage is same, V by RS. This current, V by RS I can put down. And I wish to take this current as I. This current as I. In ideal current source, we are finding the current same. It is a constant only. It doesn't have any variation only now. Even if you are changing the voltage, by changing the load voltage, we change the voltage, but current remains same. But in this case, what happens? The current I can be calculated by IS minus V by RS. V by RS. This is the way we can determine the current I. This way we can find. If the voltage you are increasing more, you think it's so. If the voltage is increased more, difference will be decreased. Difference is decreased means current is decreased only now. Current is decreased. How the variation of the load voltage will be made? By changing the RL. When you are changing the RL value, V value changes only, we can say. Understand my point now. I can draw the diagram in this way. VI characteristic curve we can draw in this way. This is the current versus voltage. The diagram is taken here now. This diagram is to be plotted like this now. It is going to move down. It is going to move down only now. Initially voltage V equal to 0, it is a short circuited. Suppose if it is a short circuited, what you can find I and IS are same only here now. There's a I equal to IS and slowly changes only now. Decrease will be done. That is the practical current source I can put now. And what are the dependent sources? I will put here now dependent sources now. How the diagram will be plotted here now. How dependent sources symbols are to be drawn. dependent sources. But different types of the dependent sources, you got it now. Voltage controlled voltage source, the symbol we can take like this now. One diamond shape is a must. This is a plus, this is a minus. So, for the V1, K into V, K into V. The change of this voltage changes the V1 only now. The change of this voltage changes V1 only now. So, V1 depends upon the voltage. That voltage may be a drop across any resistor or inductor or capacitor or any source will be given here now. Understand now? Anyhow, voltage controlled voltage source symbol is to be drawn like this now. Voltage controlled voltage source symbol is to be taken like this now. And what about the current, what now? Voltage controlled current source. I can draw like this. One current source I have taken. This current source I want to take it as a I2 or something, K into I2. There is a V1, this is a I2 equal to K into some V2. The current I2 depends upon some voltage. That V2 may be a drop across resistor or inductor or capacitor or some source will be given here now. It depends upon some voltage, you know, that is I2. This is said to be voltage controlled current source. Current source we can say now. Voltage controlled current source is to be taken like this now. And what about current controlled current source? Current controlled current source we can draw like this. This depends upon I3 I have taken here now. I3 equal to I4, I3 equal to I have taken now current controlled current source. K3 into some I. The I3 depends upon some current. That current may be passing to the any other branches only you can say. So, I3 is a current controlled current source. I3 depends upon this I. So, current controlled current source. But these are all what now? So, these are the dependent sources cannot be visualized by anyone only now. Suppose you go to any shop, so you ask, but I want one current controlled current source. He will laugh only now. It's not available. One voltage source he will give. Current source also not available. Only voltage source you can get from the shop. Understand my point now. But what about these dependent sources are? But these are all nothing but the what now? Current controlled current source means in the analog circuits you are going to draw. You are going to find collector current. Collector current equal to beta into IB. Beta into IB is nothing but the IC we are going to put now. IC equal to beta into IB. This is a current control current device you can draw. That collector current you can draw what now with a symbol of current control current device because the collector current depends upon base current only you can say. Like that what you can say in the analog circuits these are the sources we are going to use. Understand my point now. It's a current control current sources only. What about the current controlled voltage source? Current controlled voltage source is drawn like this. Z plus minus some V4 equal to K4 into I3 I have taken for example. Some current I3 or I whatever it may be. This is said to be current controlled voltage source. Current controlled voltage source. Like that what now symbols of the dependent sources to be drawn in the problems only now. Next one I want to take KCL and KVL. KCL and KVL we can discuss only now. But it takes us some time I think now. This will be discussed in the next class only now. Okay. Thank you.